Okay, sorry about that. It's been, what, a day and a half since I did the first half of this, so I'm sure I totally remember exactly where I was and what I was doing. Anyhow, so last I saw, we had sort of looked at this and figured out, let's see, given the maximum range, which you were given, right, from this little plot like that, you can then find what the launch speed had to be, and then you can basically find, this is t here as a function of v naught and g, and theta naught. Now these are known, right? So everything up front here is known, and it's just theta naught that's unknown. Same for range. So you don't really need that. I guess all you needed range for was to find v naught, right? So find that from the range thing. Maximum range comes here, la-di-da. So now at this point, t is this, t max is this. So what you can do, taking these two equations here, this and this, you're given something like t equals, I'm going to call it capital N times t max, but capital N is a red number for you, okay? That was something less than 1, 0.8, 0.9, 0.6, I've seen, whatever. Okay, so you can go and say then what's the deal? You're launched, right, so basically plug in this value for t here and this value for t max. So you can get then 2 v naught squared, oh sorry, not v naught squared, just v naught over g. Sorry, my screen is flickering in a strange way. I don't think you can see it where you are, but so plugging in for t here, 2 v naught over g times sine theta naught equals n times t max, which is 2 v naught over g. Okay, so pretty clearly now, cancel, and you say, sine theta naught, which is your, well, sine theta naught is equal to n. So n is this given thing. This tells you then what the sine of theta naught is, okay? So in the last question finally is, the question you actually have to answer is, what's the minimum speed the projectile reaches on this flight here while, when it's launched at this value of theta naught. So sine theta naught equals n. So the point is, solve. First thing to do is just solve for theta naught. Okay, you can't. There are ways to do it symbolically that are, if you're super clever. But whatever the case, so now you can take theta naught and use that as we did to decompose this into the initial y and initial x velocities. So this is v y naught, and this is v x naught here, right? And then as this thing moves, at what point is the speed minimum? Well, speed is the magnitude of the velocity vector, right? So you take these two components of the velocity vector, and the magnitude of the total vector is the speed. Or, the speed is going to be, I'm just writing this down here because I'm running out of space, but speed is going to be square root of vx squared plus vy squared. Okay, so now let's look at this. Vx naught is this, but remember what we said here at the very beginning, Vx is constant through the flight. So at any given point, you're going to have the same Vx. I'm not labeling them, but I'm going to draw these in, pretend these are all the same, okay? These are all the horizontal components. Just humor me and say they're the same, okay? Vy does change because you do have y acceleration. So it's hot, it's, big positive here, and then it goes down to sort of low positive, and then 0, and then little positive, or little negative, and then bigger negative, right? So at what point is the magnitude of the total vector the smallest? Given that the horizontal bits are the same, clearly it's smallest when the vertical bit goes away. Okay, so here, which is the very top of the flight. So one way to see it is now you start off with Vy positive in this equation down here, and then it decreases until it reaches 0, and then it becomes negative. So clearly, the square root of what's in parentheses is going to be the smallest when Vy equals 0. Okay, so at that point then, V is just equal to Vx. So this here, Vx naught, this constant, x velocity, actually is, or the magnitude of that, at least the absolute value of it, is the minimum speed you get to. So in fact, your answer is then this, v naught cosine theta, after, of course, you solve for theta naught, well, cosine theta naught, after, of course, you solve for theta naught and also for v naught here, sort of. So anyway, that's the answer, basically how to do it. And again, the problem is all about just sort of taking the pieces apart one at a time, not trying to do everything at once. but just trying to get one little bit at a time working so that you can then sort of move on to the next little step. All right.